Hello, my name is Greg Krinklaw, and I'm the developer of SkyTools. In this video, we are going to look at the powerful combination of SkyTools for imaging with iTelescopenet. If you're not familiar with it, iTelescopenet is a website where you can rent time on telescopes around the world. They have 6 observatories with 21 online telescopes available. This is their website, and the way it generally works is you purchase a monthly plan. Here are their monthly plans. So for plan 90, for instance, you spend $90 a month, and that earns you 90 points each month, and they do accumulate over time. Those 90 points are then available to you to spend on various telescopes. Some telescopes have a much higher rate per imaging hour if they're a big observatory-size instrument, but there are also smaller telescopes available that don't cost as much. You only pay for your actual imaging time. So you don't pay for slews or filter changes or anything like that. You pay for your actual imaging time, and if something goes wrong with the telescope or there is a problem with the weather, then you can easily obtain a refund. So if you don't have a backyard observatory, this is a great way to get into the game and start doing your own imaging. But there's a problem with all this. There are so many telescopes and so many projects one can do, it's very difficult to know which target objects are appropriate for which telescopes and which telescopes to use for a particular target object. And then you get into scheduling. What's the best time to schedule a particular target object? What filter order should I use? Many people just end up playing with their imaging time that they've purchased. They will take yet another image of M42. And the advantage of SkyTools for imaging is it allows you to use iTelescopenet in a very efficient way. And here, efficiency means money. Let's close this and look at SkyTools for imaging. I've already set things up a bit here. What we've got here is the target selection tool, and the target selection tool is designed to find suitable target objects for a specific telescope. The way that works is you have a list of objects. Here's your list. In this case, it's the 100 best astrophotography targets, which comes from a handbook. Lists can come from a lot of different places. We have a large number of them available for download at our website. You can create your own manually. You can create your own using various tools within the software. There's a very large, extensive database in SkyTools. It's highly corrected. So if it can be imaged, it's basically in the software. So the way this works is we pick our target list with target objects in it, and then we filter that list down. So I'm going to enable these filters here, the prime time of year filters, and that has filtered down the target list to only those objects that are best for iTelescope T33. And the way that works is I have set a maximum air mass of 1.5, which means the objects have to be fairly high above the horizon, for at least 60 minutes. So each of these objects is above 1.5 air mass for at least 60 minutes at some time during the year. Also, I have said that you have to be able to reach a target signal-to-noise ratio of 30, which is a pretty good image, in less than 60 minutes. The purpose of that is to eliminate target objects that are going to take too long. You don't want to choose a target object that's going to take 24 hours of exposing unless you really, really want to. The next thing we can do is put in a filter for the scale. And the scales are graded. I'm going to just choose objects that have a B scale. So A's and B's are showing up here in the scale column. Well, what does that mean? That means that the objects are big enough that they don't cover just say 2 or 3 pixels and you can't get a very good image. So we've narrowed it down to just those objects. The last thing we can do here is we can implement the night filters, and these filters apply to the night that we've selected, April 25th to 26th. That's really narrowed down the list of objects. Now what that's doing is it says that this object has to have an imaging quality of A for at least 20 minutes on this specific night. Now, what does imaging quality mean? That's also graded A, B, C, D. A's the best. This blue line here is the IQ line, or the imaging quality line throughout the night. The higher it is on the diagram here, the more SNR you're going to be able to achieve in a given amount of time, signal to noise ratio. So on this night, you want to image when this is very high. And this area in here is going to be your A level quality imaging time. This is M65. There are some other choices here. Let's look at the Sombrero Galaxy. That's a good target object for this telescope on this night. Let's go ahead and open a chart for it. So this is the interactive atlas. That's a Sombrero. I just turned off the crosshairs. I can open up a camera view. So here's the camera view. This is what's going to appear in the camera for a luminance filter 2-minute exposure. If we change that to a 1-minute exposure, then it doesn't show as much. So that is a true simulation. And when I did that, up popped the field of view of the camera on the interactive atlas. Okay, so now that we've picked a target object, we want to create an imaging project. So I am going to right-click on it and select Create Imaging Project. And when we go to observe with our iTelescope, we're actually going to observe the imaging project, not the object. The imaging project is our way of telling the software what we want to do, what are our goals, and setting everything up. So I'm going to just select my observing program. That's just a way of keeping track of things. These other things are all pretty much good the way they are. Here's our iTelescope T33. And I'm going to move on to the Composition and Tiles tab. So here's the field of view of the camera. It has a fixed position angle, so we can't rotate it. That's the way it is for all iTelescopes. But we can drag it. We can move it around. We could say we wanted to frame it here. And when it went ahead and took the image using the iTelescope, this is where the field of view would be. If it was a very large object, we could enable tiles. So how about 2 tiles? 2 by 2. Zoom out a little bit here. So let's say the object didn't fit. We could do this and then move that around until we could get the entire object within it. And then when we go to schedule these observations, it will schedule each of these fields of view separately, and you can put them together later to create one image. I'm going to go back to single field of view here, and let's just put it there so we can get this Galaxy 2. Now let's move on to the exposure goals. Now this is where we determine what we want to achieve in terms of exposure. I'm going to go with luminance, red, green, and blue, your classic LRGB imaging. And we could just put in total exposure time for each of those filters, but I'm going to go by signal to noise ratio instead. That's more powerful. And I'm going to tell it that we want to achieve a signal to noise ratio of 30, which is a higher picture quality in each filter. Well, what does that signal to noise ratio represent? The Sombrero Galaxy has a bright center, so it's going to be easier to get a higher signal to noise ratio on the center of the galaxy than it is in the spiral arms. And it's got a faint outer halo. That's going to be even harder to get a good signal to noise ratio. So we have to tell the software what we're exposing for. And in that case, we're going to go for the main extent or the spiral arms of the galaxy. Now, if we look over here, we can get the luminance filter to quality of 30, a signal to noise ratio of 30 in 30 minutes. But these other filters, they're a problem. It's going to take 2.8, 2.3 hours. So we're going to use a trick that many astrophotographers use. We're going to customize those filters to use 2 times binning. And when we do that, each of these now becomes much more reasonable. In fact, we can get all of these filters in 30 minutes of total exposure time. So I'm going to go ahead and close that. So the next thing to do is to schedule an observation. And I can create more than one imaging project. We've just created the one here. I'm going to bring up the scheduler. All of the imaging projects that I've created for T33 that haven't been finished are going to appear in this list here, with the best one at the top. In this case, there's just the one, the Sombrero Galaxy. I've selected the same night, April 25th, 26, and I've already narrowed it down to a range of time here. I can slide these around. I've decided that the peak imaging time is when this blue line is near the top. It's going to be between 2100 and 2200. This red dashed line, by the way, is the altitude of the Sombrero Galaxy. It's pretty high, but not as high as it gets. But the problem is once we get up here, the moon has started to rise. This is the altitude of the moon, and you can see the background is also shaded to show moonlight. So this is our best period of time to observe the Sombrero on this night. And I'm going to just block out an hour, and later on I'm going to reserve an hour of time on this night. To schedule it, now that I've blocked out that hour, I'm just going to add the Sombrero Galaxy to the schedule. There we go. And this is the schedule over here. And it says at 2100 we're going to slew to the Sombrero Galaxy, and then we're going to take 3 10-minute exposures in the luminance filter, followed by 2 10-minute exposures in the red. And that is, the red here's the slew. This is the first set of exposures. This is the second set of exposures. Now we didn't get to the green or the blue filters. It's decided to leave those for another night. Perhaps in the blue filter we want to wait until it's higher in the sky, for instance. So we're going to do a partial observation of this object on this night. We're going to come back on another night and finish observing it. So now let's set up our plan settings here. And we can turn these on and off. I always like to plate solve my images, so that will happen automatically. This is a camera that needs to be auto-guided, so I've turned on the auto-guider. And everything else is pretty much normal. We'll leave the focusing at normal automatic and exit. So now when we make a plan for the iTelescope, it will use these selections. So now I'm going to go ahead and save a plan. It's suggested a name for the plan. I'm going to override it there. And up comes the plan that it has generated. So this is the plate solve. It tells us to auto guide, the luminance, red filters. We're going to upload this plan to the telescope, and the telescope will then execute it. So the next step is to upload this plan to iTelescope. I'm going to open it here. There we are. I'm going to go to the iTelescopenet Launchpad. This is what it looks like. These are telescopes around the world. This is the telescope we're using. Note that it says available because even though it's during the day here, this telescope is actually available for use because it's in Australia. I'm going to click on it and bring it up. We're now logging into the telescope itself. It may take a moment. Here it is. Now the first thing I want to do is upload my plan. So I'm going to go to Observing Plans. I'm going to choose my file. It's the one we just uploaded. I'm going to upload the file, refresh, and there it is. So this is the one we just created, not uploaded. But I've just uploaded it now. So now this plan is on that telescope system. So the next thing to do is to create a reservation. So I'm going to click Make a Reservation. And we're doing this for the 25th of April, so I'm going to go ahead and just move ahead to the 25th. Here's that period of night before the moon comes up. This is where the moon comes up. And we decided, as you recall, that we were going to observe from 2100 to 2200, this block of time in here. So we're going to go from there. Wait, that was the wrong column. Excuse me. We're going to go from there, 2100 to 2200 or 10 p.m. and we're going to select the plan that we just uploaded. So there we go. That's our reservation. I click Confirm Reservation, and the reservation now appears. once the telescope gets to this night, and if it's clear and if the dome is open, it will go ahead and make the observations that we told it to using SkyTools for imaging. Now, let me show you a couple other little things. Let's go back to the target selection tool. And I'm going to turn off the filters. And I'm going to find the a good one would be the Cigar Nebula, or the Cigar Galaxy, I'm sorry. Open up the object info. This is information about that particular target object. Here's a view of it tonight, for instance. Any images I have attached to it, target lists that it's in, and so forth are all here. But I'm going to go to the Compare Imaging Systems tab. And what this tab does is it looks at every imaging system defined in SkyTools, and it could just be all of the iTelescopes, and it ranks them in order of which one's best for this particular target object. This galaxy's in the northern hemisphere, so it's not going to suggest any southern hemisphere telescopes. And it says that the best imaging system for this target object is T24, which is located in California. Now, why is that? That is because it is above 1.5 air mass, and I can change that number, for 9 hours. So there's plenty of time to observe this object. And that's not just on a particular night, but because it's up for so long, it means it'll have a pretty long run of a month or two that you can observe it from this telescope. The other thing is I've entered a signal to noise ratio of 30 again here, and it can obtain that signal to noise ratio in 30 minutes in the luminance filter. So this is an imaging system that can image that target object fairly quickly. If you go down here to T18, it's going to take 80 minutes, right? So this is pretty fast, and that's pretty much why it's put it at the top. But if you notice here, T21 in New Mexico is pretty close. It also takes 30 minutes. It's a smaller telescope, but it has a smaller image scale. This is the size of the object on the image. It covers 1,000 pixels in T24 and only 688 in T21. You can see that reflected in the scale score here. Higher scores up to 100 are better. And this is really why T24 was put at the top, because it has a much better scale score and yet the same short imaging time. If you have an object that you want to image, it can very quickly tell you which iTelescope you should be using, with the exception of cost. It doesn't consider that. And so let's go down here to T5. That's also located in New Mexico. It's up for a pretty long time. And we can actually obtain our signal to noise ratio of 30 in just 20 minutes. The image scale isn't quite as good. It's only 399 pixels across. But this telescope is much cheaper to use. So that might be your final choice for this project. Back to our imaging project of the Sombrero Galaxy. Go back to the scheduler here. Eventually, that night's going to come along and we're going to get images. So I'm going to go ahead and open the Sombrero Galaxy project, but this time I'm going to go to the Observations tab. Now, if you download those images, you can automatically read their FITS headers. So you enter an observation here, you go to this button, and you quickly browse to the images you've downloaded. It fills in all of this information. You click OK, and the images we took are logged. If we want, we can add an imaging quality manually. You say, wow, I looked at that image and it was awful. And if we set a minimum imaging quality of good, then that image isn't going to be used. I say used. What does that mean? Well, here we're keeping track of everything we've done. And if we haven't finished it, the next time we go to the scheduler here, it's going to schedule only those things that needed to be done. So let's say we got some really good images on this night. We got the luminance and the red. Well, now we need the blue and the green. So it will keep track for you of where you're at. And when it's done, it will be marked as completed. And when it's marked as completed, it won't show up here anymore. You will also have a record of all of your observations. So you can open the Project Manager, and this tool allows you to look up observations in any way you want, by imaging system, target object, so forth. So that's a quick overview of how SkyTools for imaging works with iTelescope. Thank you for watching.